to talk about California native bees with Dr. Gordon Frankie. Thank you for coming tonight. My name is Gemma. I work for the Napa County Resource Conservation District, and I'll be making a couple announcements before I introduce our guest. We have expanded our Wild Napa reach down into American Canyon, and they will be having their own Wild American Canyon on July 20th, right around the corner at the library down there. That will be covering endangered species of San Pablo Bay. So if you are in that area and would like to catch all of our lectures, feel free. We will be expanding northward. We hope to be doing that soon as well. So next month, also August 10th, we will be having Dr. Quentin Martins from Audubon Canyon Ranch come and talk about iconic cats and how they are superheroes for conservation. I have a poster that goes into the details about that at the front, as well as some handbills if you'd like those. This lecture series is made possible by our partners and sponsors, the Resource Conservation District, the Watershed Information and Conservation Council, Friends of the Napa River, the Carolyn Parr Nature Center, who made the adorable bee cookies. Great reviews so far. Napa Green, and our generous host, the Napa County Library. Thank you so much for this space and for your generosity. I will be passing around a 100% voluntary donation basket. Those all go toward Wild Napa and help us to continue to put on these series for everybody. So I'd like to introduce our speaker tonight. Gordon Frankie is a professor of Research of Entomology and the Division of Insect Biology for the College of Natural Resources at the University of California, Berkeley. Say that 5 times fast. His specialty is behavioral ecology of solitary bees in wildland and urban environments of California and Costa Rica. He teaches conservation and environmental problem solving at UC Berkeley, and he is the principal investigator for the Urban Bee Lab through helpabee.org. Dr. Frankie also has numerous publications, a couple of which are over on the table if you'd like to give those a gander. Bees in Blooms is displayed over there, and I think they're also available for purchase. And so without further ado, I'm going to please welcome Dr. Gordon Frankie.
Well, thanks very much for the invitation. This is a great crowd. Well, I'd like to start out by asking the crowd, can you all hear me? Is this okay? Yeah. Okay, good. That's usually people say louder. How many species of bees do you think we have in California? Species of bees. Except for David. David, you don't say anything. Okay. How many do you think we have? 500, I heard.
4,000.
Actually 4,000 species in North America. You're getting there. Okay, it's actually 1,600 different species of bees in California. We have 40% of all the bee species of North America right here in California. Why do you think that is? Weather. What else?
Diversity.
Plant diversity, I'm hearing. What else? We have an incredible set of plant communities that are very, very diverse. And when you have that kind of diversity, just think about, some of the places in the Midwest that don't have this sort of thing. They're lucky to get 300 species of bees. Florida, I think, has 350. Texas has 400. So we're way in front of everybody. And these bee species are really very interesting. Probably within this area here, if we were to do some sampling and spend about 3 years just sampling here and there casually, we'd get easily 100 species of bees right in this area. And if you had a really good garden, you might even get a few more. So what I want to do today is tell you a little bit about the bees, and also if you have some questions along the way, be sure to ask. And we'll see if we can't get people a little bit excited about this incredible assortment of bees that we have in urban environments. I can tell you from the onset that most cities where we sampled a lot of cities throughout the state, have bees and native bees, but there are a few cities that don't have bees. Anybody here from San Diego? Good. It's the worst city in the state for bees. Why? Have you ever seen the vegetation in San Diego? Lawns, calendula, and maybe a little bit of cosmos, and that's about it. We've looked several times. There's another place also that's you would think that it would have a lot of diverse bees, and that is Monterey, Carmel, and Pacific Grove. Terrible place for bees. Everybody has a gardener there, where a lot of people have gardeners, and they use the simplest plants possible. Agapanthus, junipers, things that bees don't care for. Yeah, but let me just get back to the opposite side of the coin here. What city do you think has the most diverse plants that would be attractive to bees? And it's not Berkeley. Fresno? No, they're way in the middle someplace.
Los Angeles?
No.
Humboldt?
I don't think anybody's from this particular city, but the city is Santa Cruz.
Get the slugs.
And I always ask the people of Santa Cruz, why do you think there's so diverse gardens here? If you ever walk around Santa Cruz, you should do this. The gardens there are absolutely beautiful. And they always tell me, well, we have a lot of diverse people here. So, anyway, let's get on with the show here. Okay, so here's what I'm going to be talking about. Can you still hear me?
Yep.
I'm going to tell you a little bit about the characteristics of native bees. If you have some questions, be sure to ask. Please don't ask me, do they make honey? No native bees make honey. Okay, just a little tiny bit of liquid for bumblebees, but honeybees are the only ones that make honey in North America. We're going to talk a little bit about the work we do at Berkeley in our bee garden, and then we're going to talk about statewide patterns, and then we're going to talk about how we're transitioning this information to a whole variety of uses that we never even dreamed of before. So that's what we're going to be doing. So, native bees, 4,000 species. Actually, it's United States, US, and Canada. 1,600 in California, and we have this incredible diversity of plants. 6,500 flowering plants in California. We're right up there with all the major players in terms of plant diversity in the world. So we're actually considered one of the hotspots of plant diversity in the world. California's got a special status in that regard. So here's a few of the bees. My colleague, Roland Coville, he has an incredible knack for making photographs of these bees. Here's the little carpenter bee. Most of you are familiar with the big carpenter bees that come into your wisteria. This is the little carpenter bee. It does really similar things, but at a much smaller scale. And then here's a bee that we only find in Southern California and maybe a little bit at Mount Diablo. So this you can read, 100 crops pollinated by bees. Most of these are honeybees, of course. 30% of our diet, they figure, has a pollination event that preceded it. So a lot of what you eat comes from pollination that you take for granted. And part of the reason for that is we just never tell you about how good these bees are. And it's only been recently that we've actually started to extend information out, and the people actually are, promoting more and more information, which stimulates us to give you even more. Now that brings up another issue that I'll tell you from the onset, and that is most native plants and most plants have common names, but most bees do not. And the reason for that probably is very simple, and that is people have been naming plants for years. We haven't been doing that for bees. We're just beginning to do that now. You can do official naming or you can do unofficial naming. So we have a long way to go. Here's some very important crops. You can see these. This one is extremely important, almonds. You need to have bees to pollinate. They go between trees. If you don't have that cross, you don't have almonds. So the almond growers are really aggressive in trying to get all the bees they can from all over the United States up here in springtime. You all heard those stories about, you've heard them, okay.
Are you fine? There's some people that are hard. There's some people that are hard of hearing.
Oh, okay. It's better. Okay, sorry. I thought, okay, good. That's what I need to know. Okay, so we have a lot of variation among the bee species. Every bee species has its own story. It's like every bird has its own story. Every amphibian, every reptile has its own story. So if you try to characterize and which I'm going to do tonight, of course, what native bees are all about, you find out that you have to look at specific characteristics of bees, and they have great stories to tell us. So this is a fertile ground for research, and we're involved heavily with it. We've been involved with bee research now for almost 40 years. Now these are the kind of plants that we have in California that depend upon bees for pollination. They have evolved with the bees and vice versa. So when people tell you about, well, I have a list of bees here, well, you really ought to ask them, what plants did you find them on? Because there's a relationship. Here are some of these incredible photographs. I'm going to let you take a look at these, and I'll tell you a little bit about these. I'm going to start with this one because this is a little quiz. How many of you seen this bee? 3 people. This is the second most common bee in California. And it's found almost all year round. The honeybee's the first. Okay? This thing flies fast. But I want to tell you that if you start looking carefully and get your bee eyes, hang on, bee eyes, you can begin to see these things. And this is right now this bee's flying around, the males and females. This is the most common bee, second most common bee in California. This one up here, very, very common right now in sunflowers and also in cosmos. Have you all seen that one? The other thing that's really interesting about cosmos and this bee is these bees, they joust all day long, trying to get lucky. And then at night they sleep together. Males all sleep together clustered. And people ask, well, do bees really sleep? Well, actually they do. If you go up to a flower, this is in your garden, you can do this, it's very interesting. You go up to the flower in the night or early morning, and you can touch the back of the bee, and the bee does this. No, it doesn't do that.
They're fireflies.
The bee will raise its leg up in the air like this, and it doesn't move, it just goes up like this, and then you touch it again, and the other leg goes up. Well, the damn thing is sleeping, no wonder. Okay, so here's a couple more things. This bee is really cool. You can see the belly of the bee. It gathers pollen on its belly because it has all its pollen gathering hairs on the underside of its abdomen. So it does a little shimmy across the flower. This is Gaillardia. Everybody knows Gaillardia, right? This is a really good one for this kind of a bee. But look at all the pollen. It's all over the place. Now this little bee here is really cool. This is buckwheat, and it's on this little bee is about the size of a kernel of rice. And what this bee does is it doesn't carry the pollen on its legs or on its abdomen. It actually, pollen. It carries the pollen inside a little container, a little expansion of its digestive system, and then it goes back to the nest and regurgitates. So there's 3 different mechanisms for carrying pollen: on the legs, the belly, and inside this little area of the crop. So this is some of the diversity that you have to deal with. Now I have to tell you a little story. You know, we give a lot of talks to kids and school kids, and kids have great imagination, much better than we do. So there's one kid says, "Oh, I know what the name of this bee is," and I said, "How do you know that this is this bee right here? Take a look at its face of the bee." This kid says, "That's a Batman bee." Well, we now use that. I mean, here's some more. Now this is really interesting. You can see this in your own backyard. This is a large carpenter bee going to a salvia plant. And look at all the pollen being deposited on its back. That's a black bee. This is all pollen. Look at the perfect fit there. Furthermore, look at the stigmatic surface. It's got pollen on it. You begin to see these things. And it's really quite exciting because bees are really entertaining if you just take a little time. We only have one kid in the audience. No, 2 kids. I can't tell this story. But this is a really interesting bee right here. This is in Gilia capitata. And if you notice, this bee collects pollen on its legs, and it's purple pollen. But this bee has also been to another flower as well. Look at this. All that yellow, that's all pollen. It went to another flower. So this thing is moving around. Evidence to show that these things are using more than one host. So, native bees are solitary nesters. About 70% of the bee species we have in California they nest in the ground, and they scatter their nests widely. It's very rare to find a group of bees together. The other 30% are in cavities, and this is in tree holes, or sometimes it's on the eaves of roofs, or one time we had an old car that had an old radiator, and the bees are making nests inside the radiator. And this has implications now for gardeners. I understand there's a lot of master gardeners here. Well, I have a thing in my website called Mulch Madness. And that's where people overuse mulch. And if you do that, you're covering up space that could be occupied by a bee making a nest, because they can't get through the mulch. And if you use it too thickly. Some gardeners are just nothing but a layer that thick of redwood shavings or whatever. So be careful if you're interested in having a bee nest in your garden to not mulch everything. So here's another interesting thing. Here's the most common bee, second most common bee in California. We call it the ultra green sweat bee. And look at the kind of soil that it makes nests in. Now some of these bees will actually go out and they'll get their crop full of water, and they'll come back and they'll spit the water on the soil, and then they'll scratch it, go get some more water, scratch it until they make a dent through the soil and get down to places where it's softer. So they're very resourceful. Here's a bee, leafcutter bee. Some of you probably seen these in action on your roses or on your ribes. You should be very happy that they're there. Those little circles won't hurt anything. You say, oh wow, look at this, we got some bees. Okay, let's see what else we got here. Oh, here's some more bees digging, just to show you how they dig.
Is there back?
Hmm?
Front, back legs or both?
They use all legs.
All legs.
Oh, okay. Here's the ultra green sweat bee again, female. And here she is over here digging. Here's another one digging over here. You can see the size of these bees. That's probably the reason why you haven't seen them sooner, but they're out there. And the male has striped abdomen, black and yellow. It looks like a little wasp, but actually it's a male bee. And then you can see how these things dig. I mean, they're just really industrious. They dig around. Here they are, making their nest. And if you dig down, you can see the nest. I'll get to that in a second. Now here are the cavity nesters. The cavity nesters are really cool because you can study them. You can't really study the ground nesters that easily unless you come upon a nest by accident. And we can put sticks out that look like this. They're drilled out, there's dug fur, and you put them out, and the bees come and they make nests in them. You can see where it's capped off here, 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 and here's a bee sticking his head out. If you split that stick, you'll get this sort of arrangement. It looks like a green cigar. There are about 7 or 8 cells in here, individual cells. And if you take these things apart, one of these apart, you get this. And if you take the lid off, which looks like it's been fastened as though it was making a pie, squeezing, pinching around, well, you're going to get this. You're going to get a loaf of pollen, and then you're going to get a larva developing on it. That's what goes on actually in your yard and in the environment all the time. And you can put these out, and you can do this. You can attract these things right in your backyard if you wanted to. Question, yes?
So does one bee use the same hole and put one and then another?
Yes, yes. But there are some bees that are really aggressive, and they'll actually take over a nest from another bee. So there'll be squabbles sometimes. Sometimes between different species, sometimes the same species, they'll just squabble. Usually what happens is once the female gets a nest started, she's dedicated, and she stays there, and she just fights off everybody. Well, here's another piece of information that I hope you'll enjoy, and that is all male bees, let's start the other way. All female bees sting, no male bees sting. They don't have stingers. Same thing goes for wasps, same thing goes for ants. Bees, ants, and wasps are in the same order of insects, and it's only the female that stings. That's cool. Male bees, this is a male bee. How many of you seen the teddy bear bee? This is the teddy bear bee. Have you all seen this one? I have people who write to me and say,
I had it in my garden this spring.
oh, did you grab it?
Oh, no, he was just flying around and I went in the house and looked him up. I wasn't about to touch him.
Well, I have news for you. You should have touched him because it's a great experience. This is such a docile thing. It's got a good name, a teddy bear bee. And there's a website that tells you a lot about teddy bear bees, but this is our best teddy bear bee in the state. This is Xylocopa varipuncta, and they're really common, and they should be around here a lot. So if you see these things, grab them because they're really fun. You can grab these things, hold them, they'll buzz, and you can use them if you're a teacher in classrooms with the kids. Get the kids over and say, hey, would you like to pet a bee? and the teacher, you get over here too. Because teachers need to also be able to reinforce what you're saying. So the kids come over, the bee buzzes because it's not too happy being held like this. And then after everybody's, man handled the bee, woman handled the bee maybe, then you let it go and everybody claps. But this is a great bee. This is a terrific bee and we have it now. And of course the bee the female to this is the one that goes to all of your wisterias. The big black bee, that's the female for this guy. It's a male. The Australians love this bee. They've written all kinds of things about teddy bear bees in Australia. So you might look at the literature of teddy bear bees and you'll see that the Australians have been into it more than we have.
Are they the ones that go into the salvias too?
They'll go to salvias, yeah.
They do?
Yeah.
The black.
Oh yeah, they love to go to salvias, yeah. Oh yeah, they're really into salvias. And they're also into lavenders as well. Okay, so the reason why this is the case is that females have a modified egg-laying apparatus, and that's the stinger. So the males don't have that because they don't lay eggs. And that's the reason why you can grab a male bee, a male wasp, and a male ant. They don't have anything that they can harm you with except fly away. That's their main line of defense. Okay, so here's something that people always ask me about, and that is they saw this bee 2 weeks ago and they haven't seen it since. Well, what happens is this, is that a lot of these bees, because they're solitary, they come out at a certain time of the year, they mate, and then the male dies, female goes back in the hole, lays an egg, and then it develops for the rest of the year, and you don't see it because it's underground or it's in a cavity. And then it comes out again in March. So we have groups of bees that are seasonal, just like plants. And that's why you don't see some, like you won't see the ultra green sweat bee later this year, and you didn't see it very early on either. So I'll show you a couple other things to follow up on that. Everybody got that kind of situation? Okay? So this is kind of a theoretical display of pollen and nectar. We just put this together because there are actually 4 seasons of bees in California. By the way, we have 10.5 months of active bee season in California. Just think if you lived in Nebraska.
Yeah.
Yeah, why would you want? Okay, so here's a quiz. Let's go. Let's go. Let's find out about this. See right here. This is late winter, mid-December. What's flowering in mid-December that would cause bees to come out or be around? Native plant. What? Oh, well, why don't you tell me about this? Hello. Oh, yeah. Manzanita. That's it. If you go out on a cold, cool day, 45 degrees, even a little bit less, you will see bees visiting flowers. This is the next generation for that year. Okay, this is pretty cool. There's only a few bees that do this, but they do it. And manzanitas have figured all this out ahead of time. So then we have another group of bees that come in springtime, and another in summer, and late summer, early fall. So they overlap quite a bit, but nevertheless you can sort out the bees that are going to be out in certain seasons, like the ones that are now coming into sunflower and cosmos. This is a summer bee, and they'll be out for quite a while. The social bees, things like the bumblebees, they do most of their activity up until about summer, and then they kind of peter out a little bit. But the point is, there are definite bee seasons just like there are definite flower seasons. That makes sense, because these bees evolve with flowers, and every so often during the year, you would expect a different relationship of bees to flowers because there's a different group of flowers out.
What native plants are in summer? What native plants do you?
Well, there's not that many, that's
I
part
know,
of
that's
it.
what I'm saying.
Well, I'm going to get to
That's what I'm
that question. That's a good question.
Okay.
Everybody hear the question? What native bees are out in the summer? Okay. So we have a lot of, I'm going to skip a little bit on this honeybee decline because everybody sort of heard the stories. We don't have one main reason why honeybees are declining, but these are the reasons that have been advanced: pesticides, habitat destruction, climate change, drought. We know is really hitting bees hard, and honeybee nutrition. This was a surprise to me when I talked to my honeybee colleagues. They said, "We don't know much about honeybees, what they eat." What? All this work on honeybees, you don't know what's good for them? They said, no, that's what a lot of research is going into right now. Okay, so I'll talk a little bit about our work at Berkeley. We're really interested in bee-flower relationships, and these are determined largely by humans, so the humans get into the act as well. So you've got bees, flowers, and people. So what we did is we planted all these plants with the idea of learning something about relationships of the flowers. And we did all these. In the foreground here are all natives, and in the background they're all non-natives. And non-natives are an important source of food also for bees. We'll talk about that. Now in Berkeley we have at least 88, probably 90 species of bees in Berkeley. And in this garden alone we have 60 species of bees.
How big is it?
This is about 190 feet by 30 feet.
So it's just like a city.
But, well, I haven't even shown you the good one, the record yet here. Hang on. Okay, so we want to know about bee-flower relationships. We want to know about monitoring these bees because we want to know what happens through time. Everybody's saying, well, how do we know what to do with native bees? We never follow these things like we do honeybees and bumblebees. And then we want to know about plant management. How do you manage plants to get the best blooms and so forth? And then how can you use this to develop habitat gardens? This is a big issue. So I asked my assistant Mary, I said, why don't you go out in this field out here? We might be able to use this slide one day. We use it in every talk. This is the garden when it started. This is Oxford Street here, for those of you who know Berkeley. And over here we had a bunch of plants. These were sunflowers and cosmos, and they were in full flower. I said, well, let's do this, and then over here someplace we're going to plant these plants. So we did that. We took a photograph. This is it. I only took one. And then we started carrying the plants into the field to plant them here. We had native bees following us into the field. Now this may seem a little bit, interesting and funny, but actually there's a biological reason for this. Can you think about something native plants do during the springtime? No, I'll tell you here. The story on this is that native plants, especially the herbaceous things, flower very quickly. So the bees know this, and they have to be moving all the time looking for new sources. So they have searching built into their genetic makeup. So that's the reason why if you develop a garden in your backyard or wherever, you're going to get bees right away. They'll come in, they'll find it if you got the right plants. This is what it looks like more or less today. Once again, native plants in here and non-natives in the back.
Do you know if they find the plants by sight or by chemical means, or?
Well, it's mostly visual. If you look here you can see these are mostly yellows, blues, and purples. You won't see many reds, and you won't see any really dark flowers either. And you won't see any flowers that are designed for things like flies or something like that. So we just put in the garden what bees like. We're very bee-centric. So people ask, well, how do you know if they're getting nectar or pollen? Well, I'll ask you this question. What do you think he's getting? It's a he. Nectar, right. What do you think she's getting? Well, there it is. There's the answer. You just need to look.
Is there a difference in nutritional value with pollen or nectar, or do bees do both? Or?
They can do both. They can do both in the same trip. They'll go and get a little nectar, get some pollen, go back and get some more nectar, even switch hosts. Yeah. Now these are the common flowers they like, the plant families, Asteraceae. Gardeners know all this, correct? Composites, right? Okay, composites. What are these? Mints. What about this? Borage, yeah. And Phacelias. What about this? Buckwheat. And this? You all know this one. Well, roses and all kinds of fruit trees, right? Okay. So here's some really good information right away. We spent years developing this kind of information. I've just summarized it for you in 2 or 3 minutes here. This is what bees like. If you put these things out, bees will come. Okay, some other things that we know about that also people always ask us about. Well, what about these non-natives? Well, things like Nepida, the catnip mint, they love that. They love lavender. They like cosmos. They like some weeds. How many of you have seen weeds attracting bees? Pickerus. You know what pickerus is? The bristly ox tongue? You'll always find bees in that. Taraxacum dandelions, they'll go to that. And they love to go to bindweed, which people take away right away because it's so aggressive. There's a plant that we like very much. We're going to see a slide of this a little bit later. This is called Vitex agnus castus. This is probably what we would refer to as a bee magnet. It just attracts bees just like crazy. And the trees will grow up to be 25 feet if you let them. And they just continue to pull in bees. How many of you know Vitex? You have a great plant. This is one of the very best plants that you can get in your garden. But what you may not know is that if you cut these terminals off, these flower stalks, they'll produce a whole new crop of flowers. You can get more. Some people tell me they can get as much as 3 crops of flowers in the Central Valley if you cut the tops off. Okay? I'll show you in a second what these things look like, and I'll show you where to cut it. Yes?
It was recommended to me last year to grow the Mexican sunflower, which I did, and they were all over.
Yeah,
butterflies and bees were all over.
Yeah, if you get these recommendations like we do as well from nurseries or from people that grow things, we try these things out and see if they work. We plant them in various places as well. Okay, so here's a cosmos that is pretty good. That's the sulfurous one. Okay, now we did a survey to find out what kind of relationships existed between bees and flowers throughout California. So we visited 15 different cities over a 15-year period. And we went to Redding all the way down to Palm Springs, on the coast, Central Valley. We're still sampling in Bishop, and we're still sampling in Chico, and still trying to get down to Palm Springs in a good year. So we really want to know what the relationships are between the bees and the flowers. And then we can put that information together in an Access database, so when people ask us, well, what can we use in this area? Then we can tell them. So a lot of our information is very predictable. Yes?
Is one of those spots, looks like North Bay, Napa, Clear Lake, somewhere around in there? Like the spot just north of Berkeley there.
This one?
No.
This one? That's Sonoma.
No.
Yeah, Sonoma. I'll get to Sonoma and tell you a little bit about that. The reason why we selected these cities is they were large enough and we had cooperators. You can't do this kind of work without cooperators because you barge into people's yards and of course they're really nice to you. I mean, if nobody gets real too upset with you if you got a cow hat on and an insect net and a big smile on your face. Oh yeah, come on in. Bishop is real interesting. We're getting lots of bees from the Great Basin area, which is here. It's on the east side of the Sierra, so we have a lot of work yet to do. Okay, so this is Ukiah. This is a garden. This is a really cool story. This is a garden that's 30 feet by 30 feet. It looks like it's a little bit more, but actually it isn't. And it has about 58 species of plants in here that bees like. We added a few, but most of them were here already. We sampled this garden for 3 years and got 68 species of bees out of this small garden. Here's a garden in a cemetery in the Tower District of Sacramento. And what happened was everybody died and no families came back. I mean, they're just, this is a pioneer cemetery. So they didn't know what to do, and this place was turning into a site of vagrants and drug dealers and so forth. So the city called up all these plant people and said, come over here and do something here. Get some plants in here. So there's the Rose Society, there's the Perennial Garden Society, there's the Native Plant Society. They planted all these plants. They planted the things that bees like. They're fortuitous. We already pulled 75 species of bees out of here. Now here's a garden we worked in San Luis Obispo for 3 years, and we started out the first year we sampled it. All they had were food plants and herbs. We got 5 native bee species, and then we added plants like you see right here. A number of these are ours, and we got 40 species in 3 years. And we also had to work with the gardeners to make sure that they cooperated with us and didn't spray or didn't do something stupid by screwing up the environment. But it was a very dynamic place. But we had 40 species of bees. You can do gardening for food plants, and you can add in native plants, and you can do both.
That was
Yes.
one season you went from 5 to 40.
Beg pardon?
That was one season you went from 5 to 40.
No, 3 years.
3 years.
3 years. Yes, we sampled through time. Yes.
Do you have a list of the things that gardeners do that screws it up?
I think you probably know those things already.
Okay, so you don't.
I mean, I can dig down a little bit, but anyway. So this is what we have so far. After all of our work, we have over 400 species of bees that we've collected from the gardens. Over 500 different plant types are supporting the bees. And we have all the bees have been labeled, and they're put into a database. And then we can pull the information out of the database to show you what they're actually up to. And we're getting relatively high species diversity in most cities. So this is really quite interesting. Here's some Ukiah, 95 with hardly even trying. Sacramento, 82, but we think they'll be 90 someday. So in parentheses are what we think will be there. Berkeley, we think easily 95. San Luis Obispo, 115. La Cañada Flint Ridge, which is near Pasadena, every time we go there we get new species, 130. Now just to mention that 95 is actually a pretty good number. We haven't sampled really intensively here. We only do this by net. We don't put traps out. But you have the Mayacama Mountains around, and they're supplying a lot of the bees that we think are coming into these gardens. So you're in a place where there's wildlands, and where you have wildlands, you're going to get bees coming in. They come in, they come through, some stay and some leave. But the point is that if you have wildlands nearby, you're going to get bees.
How far they fly?
That's a good question. They'll probably fly as far as they need to. We've actually marked some bees that fly 3, 5, and 8 kilometers. It just depends on where the food source is and where they want to nest. But I think it's easy for a bee to go a mile or 2 easily. And even little ones can do it. So we make counts on the plants to see which bees are coming in and which bees are associated with something like Linaria. This is Linaria purpurea, and this is in our bee garden at Berkeley. Now this is how we do this. You have to watch the bees carefully, and you might think, well, I can't do that. Jesus, these things are too small and they're too fast flying. Little buggers, you can't keep track of those little buzzers. So anyway, they come in, they may hit a flower, and they leave. Well, that's one visit. This guy came in, hit a flower here, went out, came back, hit another flower, then left. That's 2 visits. So we can keep track more or less of what bees come in and what they do when they come in, and then we record that. So that's when you have low numbers of bees coming into a plant. So for example, you can easily record 15 species of bees easily on a plant. But when you get a plant like this one, I'm jumping ahead. Poppies, you mostly get this bee here, which is the yellow-faced bumblebee, and then these sweat bees that are here. They come to California poppies along with honeybees. And if you anybody ever watch a bee in a poppy flower?
Do they scoot around kind of like that? Is that the one?
They scoot around. What else? This is great for kids because they actually roll around in the flower and get themselves covered with pollen. Have you all seen that?
Yeah.
Oh, well, you're supposed to look in your garden. Okay, so here's sunflowers. This is a longhorn bee. It's a male. You'll see these really commonly right now everywhere in California. And then you'll see this one around here. This is a relative of this one. But they love these big Asteraceae flowers. So, and then of course, I'm always saddened by the highway people. They spray these things and try to get rid of these things they call weeds. And if you buy these flowers, if you get interested in sunflowers, don't buy the hybrids, don't buy the ones that have all these colorful different petals. Get the simplest ones you can. They're called Delta sunflowers. And they're the ones in the valley that grow wild. They're the ones that are most attractive. If you get the other ones, I mean, they've actually bred a sunflower that doesn't have pollen. Do you know about that? I mean, this is outrageous for a bee person. Okay, this is one of my favorite plants also. This is a bee magnet. This is Phacelia Tennessee, also called Tansy Phacelia. And we have recorded already on this plant 60 species of bees in California. In one sample I took in Southern California, back down in Descanso Gardens, one day working for about an hour and a half, I got 22 species of bees just off this flower. So this is a really good plant. Now the other interesting thing about this plant is it's got purple pollen, it's got nectar, and you can cut this flower. If you cut it here, when it's about halfway finished flowering, it'll produce another crop of flowers. So you can do some management things that can actually keep the flowers going in your garden. This is a native, by the way. So we do an annual bee count. David's been involved with this, and maybe there may be other. Yes, there's another one, recent. We do a bee count annually. This is our 6th year we've done this in Sonoma. The NGOs there, this woman is in charge of, it's a bee. So we collect and we record this because people always ask, well, we need to know more about the bees, the native bees, and through time, because we don't have any information about native bees, because we don't know what they do. So, are we okay? I don't know. It's okay so far.
Yeah.
Okay, so here's what we do. We get everybody together, and we have a good time. We organize, and we send people out, and they do collecting, and we bring the stuff back. And then we all sit around, and we pin and label bees. We eat a little food. We drink a little bit of beverage. And we have a good time. And then we put this information together, and we publish it. Press Democrat did a story on this 1 year. We're in our 6th year. When I first learned about this is Shelley Arrowsmith, and she said, "Why don't you come and count bees?" And I said, do you know what you're asking for? And I said, well, we have to do this for more than 1 year. I'm not going to just do it for 1 year or even 2 years. She said, well, what do you think about 10? I said, you're on. So, look at here. He's right in the audience. There he is right there. Get your hand up there. Yeah. Did you learn anything?
And I know nothing about these.
Okay, here we go. So, what happened was in 2009, the USDA came to us and they said, can you take all this urban bee knowledge, bee flower knowledge, and can you take it to a farm and start attracting native bees that might be supplemental pollinators to honeybees? So we said, yeah, we can do that. So we did it. So we made a partnership with the farmers, and they invited us in, Farmer Al in particular, at Frog Hollow Farms, and we started to work there. We've been there ever since. We liked his farm a lot because he's organic, and this is Mount Diablo. We're on the east side of Mount Diablo. These are peaches and nectarines, and he's kind of a messy farmer. He likes that. He likes weeds. Not quite this bad. I mean, he'll cut these things down a lot, but the point is he doesn't spray, and he's organic. So we started working there. And by 2012, we had 8 farms, organic and conventional, and we were interested in the, if we brought in plants, could we attract bees, and would these bees then go from our plants to the crop flowers? That's what we really wanted to know. So this is what we did. We just planted. We had control farms. Not too much control here. Here we go. 4 control farms, no plants added. 4 treatment farms with added plants. And here's where we are. This is Brentwood in Northern California, by the way. Okay, everybody's with me here? This is where we are. So we've got all these farms, and these people agreed to follow our recommendations. And here's the urban area over here. It's Antioch over here. And then here's some wild area over here that we still haven't had a chance to really work on yet. So we did a lot of planting, and this is what happened. We took that Phacelia Tennessee that I told you about, and we planted it between the rows of trees. And the bees liked it. Over here we planted poppies. There was no poppies in Brentwood. I couldn't believe it. There were no poppies there. How can this be? Anyway, this is Farmer Al. He liked everything we did. And here he is. This is Vitex. And if you cut these flowers off, right about here, and right about here, you'll get new flowers. There'll be a whole new crop of flowers. Until the plant gets up to about 15 or 20 feet, then you have to figure out what you want to do with it. But you can prune these things, and you can manage them. We also put salvias in at the end of the rows of trees. These are apples here. Farmer Al loves what we do. And let's see here. Oh, this is Dwelly Farm. We planted rows of lavenders and ceanothus, and over here we have gaillardia. These are berries over here. These berries are very attractive to native bees, and then you get these beautiful fruits. And we also planted between the rows and places where the trees were dying. He says, yeah, throw seeds in there. Okay, that's fine. So we planted some natives in there and attracted bees. So this farm, which is a conventional farm, has attracted 74 species of bees. This little graph is a little teeny bit out of date, but this is a conventional farm, attracted 74 species of bees. And we think the reason why it did the attraction is because the Dwelly Farm is right up against the urban areas in the area. So we think urban areas, and we know the urban areas full of urban plants that bees like, the bees are moving in. So this is pretty cool. So we record things like, let me go back here. We record things like the number of species, which is this. These are samples we've taken, standard samples we've taken each year. And then the abundance is this. Now here's something interesting that happens that we didn't plan on, but we're pretty excited about it, believe it or not. This is Wolf Farm, conventional farm, and 64 species of bees. But his farm is right up against a creek, Marsh Creek, and it's loaded with all kinds of trees, mud, water. A lot of bees need mud and water. They don't need the water so much to drink, but they need it for the mud because they make their nests out of mud. Oh, here's one. This is a good one. This guy decided to sell his property. So he changed the farm ownership right here, and the bees went whoop, just dropped right off. And the new owners came in, and they were fixated on cleaning. They got this cleaning gene, okay? So this is what they did. They cleaned everything out. So this is what happens when you clean too much. You wipe out the food plant. There's no reason why a bee should be here. There's nothing unless they want to dig a hole in the ground and make a nest, but all the plants are gone. So when you start doing long-term research, you're starting to get changes that take place. And this is sort of the dynamics of farming in Northern California in small farms, which we think is really interesting. Now here's some of the native plants. Sorry, not native. This is a non-native weed. This is bristly oxtongue. Native bees like it. Honeybees like it. So we tell people, don't be so eager to knock every weed out of your garden or out of your orchard. You can do it eventually, but some of these things are going to feed bees. So where do these bees come from? Well, we think they come from these hills, for one thing. They come from fallow areas. If you notice in Brentwood, the area is just pockmarked with fallow areas. So there's a lot of bees nesting in the ground. They also nest right inside of these cherry orchards. And this happens to be a conventional cherry orchard. We found bees nesting in there. So after all this work, we now realize that we've used 80 different species of plants. These are almost all ornamentals, by the way. They're a mixture of natives and non-natives. And we've already attracted 127 species of bees to Brentwood Farms. Yes?
Did you select specifically for species you thought would be present in the area
We-
based on other surveys?
We selected plants that we knew would bring in certain groups of bees. We didn't know what species we're going to get. So groups of bees we knew. Like salvias, we knew we're going to get certain things. Lavenders, we knew we're going to get certain things. So here's kind of a list, a short list of all the groups of bees that came in. Now these are the same ones that also go to our plants and also the crop flowers. So it's actually all of our goals were satisfied by this work. And here they are. This is one that comes out only in the spring, usually in March. This is an osmia, a leafcutter bee. This is a bumblebee. One of the real common bumblebees actually goes into bird nests as well. If you have bird nests and you've noticed bees going into your bird nest box, that's the guy right there.
So did the crop production increase?
No, that wasn't our goal. Our goal was to just demonstrate that, first of all, we could set up these gardens and they could be sustainable, which meant we had to work with the farmers to establish a relationship. That's kind of overlooked a lot. The second thing is we said, well, let's monitor the bees through time, which we did, and then we can find which bees are going to those flowers that we're really interested in. And then we can actually do something about those flowers by enhancing what they like. Through our access database, we just go and pluck out the flowers they like. So we satisfied all our goals. People ask me that question, and if you think about this, let me just put it to you this way. You have a 100-acre crop. The farmer gives us 1/4 of an acre and says, what can you do with 1/4 of an acre? Well, we can develop a garden, we can attract some bees, but we can increase your food production. That was never our goal to begin with. But our goal, long-term goal, is a conceptual goal, and that is if one day the honeybees become too difficult to manage because they have too many problems, people are going to ask, well, what can we do with native bees? And we'll have the research ready for that. Okay, that's what we're aiming for. How many of you are beekeepers and know something about the costs of hives? Here's one back there. What do hives go for? How much?
$500.
$400 to $500 a box.
Yeah, you got a deal.
Yeah. So the cost of these things continues to go up. This is another statistic you don't even think about. And of course now we have a whole new industry of honeybee rustlers that are out there, picking off these boxes in the middle of the night. Yeah, we got the West out here, the Wild West bees. Okay, so if we get a point where we cannot really manage honeybees anymore, they're not doing the job, maybe native bees have to be looked at. And if we'll have the research for it. Our problem is, and here it is right here, is we are needing to know how bee ecology and farming ecology go together. So we've partnered with farmers. Farmer Al is here, and he says, I love what you guys do, but he says, I'll never be able to name these bees. I don't even know if the darn things are out there. You have to tell me. So we're concerned about the fact that implementation research has to also accompany basic research. So we're trying to figure out how we can communicate with farmers in the future, and we come up with a number of different ideas. I won't have time to go into these today, but the point is that we need to know how farmers make decisions. And they're telling us, we do the interviewing with them. During the growing season, when the farmers are really active, we visit these sites 2 to 3 times a week. So we know what the farmers are doing. And that way we also know that they'll call us if there's a problem or they're going to change something. Then we can keep track of that, we can do something about it. Now here's a beekeeper that was really smart. We had all of our bee plants along the row here, and he suddenly took all of his hives, there's 76 boxes here, and he moved them right next to our bees. He was thinking, that's what beekeepers do, they move their bees to places where they can get food. We also do outreach. We do a lot of outreach, especially in CSA farms. You all know what CSA farms are? No. What are they? Community supported agriculture. You get a box of fruit, you get a box of whatever. So we go out to the farms on harvest days and on blossom days, and we give tours and tell people all about these bees. We also do bee condo work. We want to know if we can attract bees to these little holes that we drill, and we can. So beyond Brentwood, we also work in avocado orchards in Ventura. We took our model down there, and we just started the work. We've been there only 3 years. But if you ever wonder about avocados, they need bees. The thing about avocados is, I didn't realize it, you have to climb hills. This is what they plant. I don't know why they don't plant on flatlands, but I guess it's just the tradition. It's a real interesting crop. Nobody knows much about how these flowers are pollinated, because one day a tree will have all male flowers, and the next day there'll be female flowers. And sometimes it's a mixture. And no one quite understands the cycles. So one person told me, why don't you study this? And I said, no, I don't want to do that. I want to study the bees that come in. I want to see if we can bring bees in. Of course, they're having severe droughts down there, so that's a problem. So we set up gardens down there. Here's the nice thing about working with avocado growers is they seem to have resources. If you've checked on good avocados, they cost a lot of money. I didn't realize how expensive avocados really are. The organic avocado growers down there tell me they can get $3 to $3.50 a piece for avocado. So these guys, they have resources. So I said, can you help us? And they said, yeah, we'll get us a bunch of guys out here. So they brought a bunch of guys, and they brought all this piping, and they dug the holes. I brought the plants, and they planted everything for me. So now we have a beautiful arrangement here. This is what it looks like now. And we're hoping that these bees will move over next year into the avocados, which are right over here. Here's another one. This is the Phil Ranch. These people really have a lot of resources. And they planted all these plants for us, and they go out there and they weed for us as well, which is really cool. Because we have a small group of people in our lab. And we're growing these plants, and we're certain they're going to attract bees. They actually, as soon as you plant these trees, as I mentioned before, as soon as I plant these plants, the bees will come, and they did come already. So we actually have seen something happen within a matter of a month of planting these things. Okay, so conclusions. Here we go. We can attract diverse native bees to urban and agricultural areas. I've only shown you a very brief list. One of my assistants has a list that's got about 50 different species of bees that we've been able to attract that go from our plants, the installed bee plants, to the crop flowers. We can synchronize the flowering to some extent of the crop plants with the bee plants. That's important. We can attract native bees to crop flowers. We think that a partnership in the future is going to depend upon new professionals. And we think this person is going to be called a pollinator habitat advisor. Because, I mean, you're talking about a person who can deal with bees and flowers. How many people can do that? And we think farmers can actually incorporate that, especially if they have to, and especially if the honeybees keep declining. So this is what we think will happen in the future. We'll call it a pollinator habitat advisor. We're now currently analyzing the business and economic aspects of implementing this information that we've got. We want to know how farmers make decisions. So we do intensive interviews with them, none of the information of which we are able to share with people because we signed contracts and said we won't share this. So they tell us a lot of things that, big secrets. Our limitations for doing this kind of work are pretty simple. We need more space. We need more than 1/4 of an acre in a 100-acre crop field. We need more nesting information, and we need farmer adoption. So that's where we are at the moment after 6 years of research. We got funders? Thank you.
If a kid is going to college and wants to study this, what would that person do?
Well, you get yourself an education in natural resource management, and then you begin to get interested in plants and bees and things that visit flowers. There's going to be a place for that kind of a person in the future. We know that already. Anybody else? Yes?
So I missed the first part of your lecture. So is there funding available? If you wanted to donate your land and say go for it, is there funding available for the grower and?
Yeah, the Natural Resource Conservation Service actually provides funding for farmers who get involved with us. So they provide funding for some of the research that we do. We also get some of our funding from the Conservation Committee in Martinez. And we also go for large grants from the USDA.
Is it up to the owner to provide the irrigation system?
We have every deal is worked out independently. So some do and some don't. We just have to ask them, are you willing to help us with this? Because we can't do it all. And most of them do. Most of them really want the information. They want to help. Yes?
How hard is it to learn how to key out bees? And do you have any resources that might be helpful for people who want to learn how to do that?
Well, we do have resources. We can teach you how to identify them to the generic level. We're actually working on portfolios, and we're working on large booklets that show the bee close up. We'll have a lot more information in the future. We didn't have that years ago because no one cared. But now we have motivation for doing that. So we'll have a lot more information. We also teach a bee course. And we teach people how to do this. There's a bee course going on, I think, this weekend in Chico. If any of you are interested in knowing how to do some of this. But it's like, for example, the California flora is all in one book. Got this nice big chunky book. But that's not how we get information on bees. They're all separated in little individual papers. So it's scattered, the literature is scattered. You have to be a real investigator to be able to get names on a lot of these bees. You can't just send a bee into somebody and say, what's the name? So we have a long way to go with bee identification. Yes?
We had a lot of success at a school in Napa, borrowing a collection from Cal Academy. We happen to have a really fortuitous partnership with UC Davis School of Education, and we did a citizen science project. And so there's lots of resources available for your citizen science projects. My question for you is actually, do you have any advice for 5 or 6 or 8-year-olds who are engaged in this kind of work, but they're not into collecting and capturing and pinning because they have a real emotional attachment to the individual organism without an understanding of.
Yeah, well, first of all, you have to get a teacher that's willing to help you.
Yeah.
You have to have a dedicated teacher.
Actually are apprehensive as well.
Well, then you have to, I don't know, you get with it, you know. Okay, I'm going to get on to something. This is something that will help you. We actually have to kill a few bees to get the names because we have to throw them under magnification. These are half the size of a kernel of rice. You cannot see these you cannot determine what it is unless you kill it and put it in a collection. The kids don't like to do that. They go, ah. So the way we do this with kids, especially if you have larger bees, is this is really easy. You collect the thing with a net and you put it into a bottle, like a glass bottle, and you put it into the ice chest and you cool the bee down. It takes 20 minutes, maybe something like that. Then you take the bee out, put it in your hand and show the kids. And your hand warms the bee up, and eventually the bee, warms up to the point where it flies away. So the kids get to see this, and they get a little magnifying glass down there. Yeah, look at that thing, and they get a chance to see what it looks like close up. So this is an easy way to do it. You don't kill them. That's fine. We have some people that don't want to work with us because when we tell them, well, we have to kill a few bees, they go, no, can't do that. Yes.
Do you foresee a time with climate change and everything else, and lawns going to the, getting rid of lawns, that there'll be more of an outreach for just residential people to do a lot of this?
Oh, heck yeah. We see that all the time.
So it's happened?
Oh, yeah. Anybody here convert a lawn into a garden that, look here, look.
Anti-lawn. Cash for bee plants.
Okay. Yes, what?
So if you go to helpabee.org, what do you see there?
You see all of our projects, and we see all of what I've given you here already today. And you also see a lot of community action. We put a lot of people into the works in our site to tell people how to do things. Because communities and people groups, social groups, have more ideas than we do. And they put things into action that we would never do.